My president says the future
is electric, and there's no turning back.
So the electric vehicle revolution isn't just on the horizon, it's here. Governments around the world are passing legislation to limit or ban petrol and diesel cars within the next decade.
Gasoline cars are driving us toward climate chaos. We actually have to stop using fossil fuel vehicles.
California's governor made that an executive order.
We will eliminate the sales of internal combustion engines.
Governments everywhere say they plan to do that.
The government has a vision for a future where all our cars will be electric.
Washington will be shoveling out tens of billions of dollars in subsidies, tax credits, and loan guarantees to push EV sales.
According to the latest research, 1 in 5 electric vehicle owners in the United States exchange their eco-friendly cars for gasoline-powered vehicles. This trend is most common in the state of California, which is the leader in the U.S. in the adoption of electric vehicles.
When swapping to an EV, your range is usually cut down by half or even more. And it doesn't help that cheaper EVs have a significantly lower range, which most drivers would struggle to get used to. In the past, shockingly bad charging times and ranges have made EVs totally unsuitable for anything other than trips to work and back.
The range of how far a car can drive on a single charge is improving, but still remains a concern for some buyers. Tesla's Model S leads the industry with a range of 402 miles, while other manufacturers can be anywhere from 100 to 250 miles per charge.
Whatever the touted range of an electric car is, the actual range in real-world driving is invariably significantly less, not just a little, but significantly less than advertised. And there was an interesting article posted by Jalopnik about this topic, and it's interesting on a couple of levels. It's interesting because Jalopnik is an arm of Huffington Post, and Huffington Post is very left liberal and thus very much apologetic and defensive when it comes to electric cars. But nonetheless, they posted this article in which some of their reporters did some testing of a number of electric cars, 6 of them in fact, and every single one of them got double digits less mileage than advertised. Now, I want to kind of put that into context. If you can imagine the hullabaloo that would result if any other type of car, any other car company was caught advertising, let's say, that its car would give you 40 miles per gallon, but in fact out in the real world you only got 27 miles per gallon, something like that. There would be a shitstorm. There would not only be a shitstorm, there would be a federal prosecution probably of it. In fact, there have been. Hyundai and Kia, same company, were recently the target of exactly that, over a 1 mile per gallon difference. And it's not just that it's a chip and that it's misleading, like buying what you think is a pound of bacon and it actually turns out to be 9 ounces or 8 ounces of bacon. These electric cars are getting away with claiming that they go a certain distance when in fact they go nowhere near that distance, and as a result of that are emitting significantly more carbon dioxide emissions than they're claiming.
How many mechanics in your area deal with electric cars? Although EVs generally require less maintenance, if your EV has been caught in an accident, you'll probably need to visit a workshop, and it's very likely you won't be able to tow your car to your neighborhood garage. Well, if you live in a place where everything comes right to your doorstep, like Dubai, that's not such a problem. But then there's the matter of exorbitant fees. EVs require less maintenance because they have fewer moving parts. If a gas-powered car has 2,000, EVs will have about 200. But less mechanical parts doesn't mean less problems. EVs have complex electrical components like power steering motors and high-voltage relay banks, not to mention the giant battery packs sitting below your feet. The battery pack is the most important part of the vehicle, and it's more expensive than the motor itself. The state of the battery determines everything about your car. If you keep it out when it's too hot or too cold, it can get damaged. If you charge it too much, the battery can die. An EV battery also has a lower temperature operation range of 59 to 113 degrees Fahrenheit, as opposed to an internal combustion engine which ranges from -30 to 122 degrees Fahrenheit. The components of an EV battery are also highly flammable, and it can start a fire at almost any time. Manufacturers have tried to fix the issue by separating the battery into smaller cells with firewalls to prevent thermal runaway from occurring. Typically, an EV battery should last 10 years. It loses its capacity by about 2.3% every year, so you could still drive the car normally, but you'd have less and less range as years go by. Replacing a Tesla Model 3 battery is about $13,500 for a 75 kilowatt-hour battery pack, and that's not including the fee for the person who will replace it for you.
Standard home outlets in the States provide only 120 volts, and this is absolutely not enough to charge a car in a couple of hours. With this voltage, it may take at least a day to fully charge a 60 kilowatt-hour battery.
In case you thought we'd be able to give you a precise amount of time for how long it takes to charge up your car, then it's a bit more nuanced than that, because it depends on the speed of your charger. A typical 80 kilowatt-hour battery pack will take around 11 hours to fill up when plugged into a 7 kilowatt home charger. You could plug into a 3-pin plug, but many manufacturers advise only doing this as a last resort. You won't get more than 3 kilowatts from a domestic socket, and the reality is you'll probably get even less. For a car with a bigger battery, you'd be measuring the charge time in days rather than hours. Fast chargers that deliver as much as 350 kilowatts are now available, making for super quick recharges. Cars that are capable of charging at higher speeds can go from nearly empty to 80% in under 20 minutes. But just because a charger is capable of a certain output doesn't necessarily mean you'll get the full beans for the whole amount of time that the car's plugged in. On a rapid charger, it's common for the peak supply to start decreasing after a few minutes. And if multiple chargers share the same electricity supply, then the output per plug could be decreased, or the car may throttle the charge in order to preserve battery life.
In the US, if you wanted to drive directly from Dallas to Denver, two major American cities, using a base model Tesla Model 3, you just couldn't. There's a 226-mile or 363-kilometer stretch with no DC fast charger between Amarillo, Texas and Trinidad, Colorado, which, given the elevation gain, the car would not make. While Tesla is plugging this gap soon with a new charger in Clayton, New Mexico, that won't solve the problem for every single other EV on the market, since the charging systems are not compatible. Simply put, mass market consumers are not going to buy cars that can't drive from Dallas to Denver.
Well, we're not off to the best start because I've already lost 3 miles of range just loading up the trailer and pulling out of my neighborhood, which, maybe a quarter of a mile. Hopefully that's not how it is for the rest of this trip, but this trailer, like I said, it's aluminum, less than 1,500 pounds. This truck shouldn't even feel it. Well, I am not very optimistic here because we have already used 20 miles of range to go 10 miles, not even halfway to the Car Wizards, with an empty, very light aluminum trailer, and the range is dropping that quickly. I don't think this truck is going to get anywhere close to getting the job done today. I mean, look at the mileage. We're at 167. It's dropping like a stone with an empty trailer. All right, pulling into my neighborhood, and we got the driving range low warning. 50 miles remaining. Are you kidding me? That's almost 90 miles of range in 30 miles? Are you serious? That's nuts! What a joke!
Recently, Car and Driver conducted a test at a Media Day event, and they were able to pair the 3 biggest and only EV production trucks available right now. Trucks from Ford, General Motors, and Rivian with a true towing test, and it shed light on the real weak spot in electric trucks' armor when it comes to real-world truck usage. For the test, Car and Driver used the Hummer EV from GM with a towing capacity of 7,500 pounds, the F-150 Lightning from Ford with a 10,000-pound towing capacity, and the R1T from Rivian with an industry-leading towing capacity claim of 11,000 pounds. Car and Driver paired the 3 electric trucks up with a very modest 6,100-pound 29-foot recreational travel trailer. It's one of those things you'll see on the road every weekend that most families realistically attach to their truck for weekend adventures. When the test was complete, here were the numbers. The Hummer EV performed the best at 140 miles of driving range. The F-150 Lightning scored a final distance of 110 miles. And the Rivian coming in last place with a mere 100 miles of towing range with a roughly 60% weight load for a claimed 11,000-pound towing capacity. To put that in perspective, I previously owned a Ram 2500 back in 2019, and that truck, when pulling a 10,000-pound trailer, even in high elevation near mountains, would still get 200 to 300 miles per tank, essentially 2 to 3 times.
Although EVs aren't the only cars that can be hacked, they are more vulnerable to attacks. The problem is EVs are increasingly high-tech, which leaves more opportunities for hackers. As more electric cars are connected to the internet, they get easier and easier to discover and attack. And it's not just a data breach or getting your car stolen you need to worry about. We're talking about tons of metal here, which can be steered remotely and potentially cause massive destruction to public property. And also, injure or kill people. And this isn't a far-fetched idea. It was shown to be possible when a Chinese company hacked a Tesla Model S in 2016. Well, Tesla has fixed that problem now. But for how long? The continuous clash between the hackers and manufacturers means the risk of being hacked will always be there.
Infrastructure is a challenge. Charging stations don't turn a profit the way gas stations do. Hence, the government is ponying up cash to construct them. And how well will states maintain them? The number of electric charges needed to replace what gas station pumps provide today numbers some 9 million, almost 20 times what Washington plans to build. The immense increase in electricity necessary for these EVs will stress out an already strained system. Remember last summer, California's EV-loving governor begging people not to charge up their cars because the grid was in trouble? EVs and their 1,000-pound batteries are not better for the environment than the internal combustion engine. Energy expert Mark P. Mills points out an inconvenient truth. Quote, one typical EV battery entails the mining and processing on average of 500,000 pounds of the earth. Building an EV entails a 300% to 400% increase in the quantities of minerals that must be mined and refined. And as a recent study showed, over half of all the locations where new mining will be needed are located in indigenous lands that are often ecologically fragile. End quote.
I'm amazed talking to people who are all excited about their electric car and they say, and I'm not polluting. And I say, where do you get the electricity from? And they don't know. They don't know that most of America's electricity comes from fossil fuels, natural gas and coal. Just 12% comes from wind and solar. Yet auto companies tell us
electric vehicles in general are better and more sustainable for the environment.
She's a Ford engineer. She's not ignorant.
Well, actually, she probably is ignorant in the literal sense of the word. She's not stupid, but ignorance speaks to what you know. You have to mine somewhere on Earth 500,000 pounds of minerals and rock to make one battery.
Batteries are made up of a mix of metals and minerals, including nickel, cobalt, lithium, graphite, and copper, that come from all over the world. A significant shortage of battery materials is looming in the near term for materials like lithium, nickel, cobalt, and copper.
Right now, demand is outstripping supply 5 years down the road, correct?
That's correct.
How worried are you about it?
Well, I am pretty worried that this could become a bottleneck to electrifying everything that people are hoping to do. As the demand for electric cars continues to grow, it's going to put more stress on those commodity markets.
And worse, ingredients in batteries are mined in places that enslave people and use child labor.
An army of children are at the heart of the mining production. Wearing no shoes and in the most wretched conditions.
Most Americans proudly driving electric cars don't know about this. They just don't want mining done near them. But wherever it's done, mining is a dirty business that adds lots of carbon to the air.
If you're worried about carbon dioxide, the electric vehicle is emitted 10 to 20 tons of carbon dioxide before it even gets to your driveway, before you drive the first mile and plug it in the first time.
We're a democracy, and there's the problem that most people don't want EVs.
Stop and think about it a little bit. If these electric cars are so fabulous as we're constantly told, there would be no need for either the subsidies or the mandates. People would simply buy them.